So sometimes we cannot solve simultaneous equations by elimination, which is the method that we already know. And if we were to draw the graph if we were to draw the graphs of the equations, that might be really complicated too. So there's another method we can use if either of those aren't working for us, and that is called substitution. Now, we've got our two simultaneous equations here, and we're starting off with a particular example where the y or the x is always the subject. So for this first one, we've got y as the subject for both of these equations. So to solve this, all I need to do is to substitute the expression that I know for y. So in this case, I know that y can be found by doing 2 times x add 7. So I can substitute all of that expression into my second equation. So if I do that now, you'll see that we end up with a nice equation with unknowns on both sides. But we've gotten rid of all of our y's, so now it's a nice easy equation with only one variable. I've only got x's this time. As simple as that. I substitute in whatever I know to be my value of y, and in this case the value of y is 2x plus 7, and I substitute it into my second expression, my second equation instead of the y. It's gotten rid of all of my y's, and now I can solve this equation just like normal. I'm going to subtract 2x from both sides, and I will get 0 add 7, so that's a positive 7 on the left. 3x take away 2x is x, and I'm going to add 3 because there's nothing changing the add 3. And I'll subtract 3 from both sides, and I'll get 4 equals x. So the first part of my solution is x equals 4. Same checks as normal. I'm just going to rub out my working out here so I've got some more space. If we do the same check as normal, or rather the same way as normal to find my second variable. So my second variable is y. I'm going to substitute x equals 4 into one of my equations. So let's lumber them again. Equation 1, equation 2. I'm going to substitute it into equation 1. Well, y equals 2 times my value of x, which is 4, add 7, so y must equal 8, add 7, which is 15. That's my y value. Let's write that over here as part of my solution. Checking it in the same way, we used equation 1 to work out what y was, so I'm going to check by using equation 2. So substitute x equals 4 and y equals 15 into equation 2. If we do that down here then, so my y is 15, so y is equal to 3 times the value of x, which is 4, add 3, is that true? Well, 3 times 4 is 12, add 3 does indeed give me 15. So that tells me that my solutions are probably correct. So that's the first kind of example where we already have either the y or the x as the subject of the formula. If we have a look at another example here then, in one of my equations the y is the subject, but in the other one it's not. It's part and parcel of the equation. Now I could rearrange and do the same method that I used on the previous question, or I can just substitute as it is. So I know that my y is the same as x plus 2. So I'm going to substitute x plus 2 instead of my y in my second equation. So let's take the 1 and the 2. And I'm going to substitute 1 into equation 2. So y is equal to x plus 2. Well, first of all, we've got 2x. That hasn't changed. There's no y's there. And then I've got 3 times whatever my value of y is. And we know that my y is x plus 2. That all equals 26. I'm going to expand my brackets. So I'm going to get 2x plus 3x plus 6. Thought that said 12 for a moment there. 3x plus 6 equals 26. Okay, I've got two variables here. I've got x's. So I'm going to collect them together, and I've got 5x plus 6 equals 26. Well, I'll subtract 6 from both sides, so 5x equals 20, and divide by 5 on both sides gives me x equals 4. There's my first part of my solution then. X equals 4. Halfway there. Now we need to substitute to find out what y is to get the second part of our solution. And again, we can just substitute that into the simplest equation, which is equation 1. So if I do that now, substitute x equals 4 into 1. Y is equal to x, which is 4, add 2. So y is equal to 6. Really easy substitution there. And there's my second solution. The check is exactly the same as in the elimination method and the method that we just used on the previous slide. So I'm going to substitute my x value and my y value into my second equation. So substitute x equals 4 and y equals 6 into the second equation. 2 times the value of x, which is 4. Add 3 times the value of y, which is 6, should give me 26. So 2 times 4 is 8. 3 times 6 is 18. And if I do 8 add 18, I get 26. So my solutions are probably correct. And that's how we have a go at another method of solving simultaneous equations, this time using substitution. Okay, there's one for you to have a go at. Pause the video. It's very, very similar to the last example, so pause the video and have a go there. Okay, hopefully you've had a go. You've substituted in equation 1 into equation 2. If I do that very quickly now, we will see what our solution is. So I'm going to have 2x plus 2 times x plus 1 equals 26. The reason for that, I know that y is equal to x plus 1, so I substitute that expression into my second equation. Expanding, we get 2x plus 2x plus 2 equals 26, so I get 4x plus 2 equals 24. 4x equals 26, sorry, skipped ahead of myself. 4x must equal 24, so x must equal 6. That's the first half of our solution, x equals 6. If we now substitute so we can work out what y is, let's substitute into equation 1. Substitute x equals 6 into equation 1, and I will get y equals 6 plus 1, because my x is 6. So y must equal 7 as the second part of my solution. Y must equal 7. Same checks as normal, just to make sure that I haven't made any silly mistakes. It's very possible. So I'm going to check by substituting x equals 6 and y equals 7 into my original equations. So I'm going to choose equation 2 this time, because we used equation 1 to work out what y was. So 2 times the value of x, which is 6, plus 2 times the value of y, which is 7, should equal 26. 2 times 6 is 12, plus 14 should give me 26, and it absolutely does. So my solutions for x and y are probably correct. Hopefully you had a go at that one and got it correct. If you didn't, go back through your method, try and identify where you made a mistake, replay the video if you need to. Okay, the last kind of question that you might need to have a go at, let me just check. Yes, it's definitely my last one. The last one that you might want to have a go at is one where neither of the equations are the subject. So if we look, for example, at the first example, we had both of them were the subject. There was a y on its own. In the second example, one of the equations had a y as a subject. In the third example, one of the equations had a y as a subject, but in this one, neither the x nor the y is the subject. It doesn't matter which one you choose, you can substitute either. And the easiest one looks to me to be the first one. So I'm going to rearrange equation 1, and I'm going to get x as the subject. So if I take x subtract y equals 1, I can rearrange it because I can add y to both sides, and I'll get x is equal to 1 plus y, or y plus 1. So that's the equation that I'm going to use. I'm going to call that one equation 3. So equation 3 has x as the subject, and I'm now going to substitute that into equation 2. I'm not going to substitute it into equation 1 because that's the one that I rearranged. I am going to substitute it into equation 2. So if I substitute equation 3 into equation 2, I will change my x to 1 plus y. And I've gotten that from my rearranged equation here. My x is equal to 1 plus y. So I've got 1 plus y in place of my x, and then I'm adding on another y, and my solution is equals 3. Collect that, so it's a nice easy equation. Collect my y's and solve it. Subtract y from both sides. That's a really simple solution of y equals 1. That's the first part of our solution. We've calculated y first this time. That doesn't make any difference whatsoever. We repeat the same steps as normal to work out our other variable. So I'm going to substitute my solution now. Y equals 1, and I can substitute it into either equation. So substitute y equals 1. Let's substitute it into equation 1. X take away 1 equals 1. So x must be equal to 2. That's the second part of my solution. Same check as normal, slightly harder question, but the same checks happen as normal. So I check by substituting x equals 2 and y equals 1 into the equation that I didn't use. So I haven't used equation 2 yet, so I'll substitute into that. Y equals 1 is, okay, so equation 2, x is 2, so 2 plus y is 1 equals 3. So that must be correct. X equals 2, y equals 1. And that's the same check. That's a slightly harder version because you had to change the subject first, but the same skills apply throughout. So it shouldn't really be any more challenging than the rest of them. Okay, if you need to practice any of these examples, you can see the references on the different questions. So you're looking at section A for the first type, where you've already got the subject, where the y or the x is already the subject. Section B, where one of them has the subject, so where x or y is the subject in only one of your equations. And then if you want to start to look at the harder ones, then you're looking at section C, so the ones we have to rearrange first. Okay, close your video, have a go.